Welcome to our next video on CodePeer. Here we're going to be delving into a couple of the more advanced features of CodePeer. We've already given you somewhat of an overview of CodePeer and focused on the particular kinds of checks and messages that it can provide to you. And as we mentioned in some of those earlier videos, the way CodePeer works in each subprogram is that it processes each subprogram essentially bottom up and tries to discover what are the possible values of every variable and every expression at every point within the subprogram. And once it's determined that, it allows it to go through the individual statements of the subprogram and find places where, if a variable has a certain value or an expression is above a certain value, that it might cause some sort of a problem. And that might be recognized as perhaps a pointer might be null, or an index might be out of range of an array, and so on. So that's very useful line-by-line basis. But there are also some interesting things that CodePeer can do for each subprogram as a whole. Because of the level of analysis that it performs, it learns things about every subprogram. And not only about what an individual subprogram does, but everything that subprogram calls. So essentially, it can determine for a given subprogram what are the global data objects that it references or that it updates. It can determine, are there any limitations on this subprogram? It can infer what we call a precondition. If you don't satisfy the precondition, there's some possibility the subprogram may fail because some check will fail. For example, if you pass in an integer value into a subprogram and it's used within that subprogram to index into an array, well, then if that index is outside the bounds of the array, there's a possibility that the subprogram, or even a likelihood the subprogram, will fail. And that limitation may not be necessarily directly visible in the specification of the subprogram. CodePeer, though, is able to analyze this subprogram and come up with what we call inferred precondition that it will then check every place where that subprogram is called. Furthermore, it displays that precondition to the user, which allows the user to first understand the subprogram better and also check whether it actually conforms to the requirements for the subprogram. It was expected to handle all values, let's say up to 100,000, and CodePeer has determined that if one of the inputs goes above 10,000, there's a danger that might be some sort of a failure, an overflow or a range failure. Then that's something interesting for the subprogram. So we call this as-built documentation. And the kinds of as-built documentation that are inferred by CodePeer are of various sorts. Preconditions is the one I've talked about so far. Postconditions are useful as well. They tell you if a subprogram has some output. It could be an output through a out parameter. It could be an output in a global variable or something in the heap. For all of the data that is updated by a given subprogram, CodePeer infers a postcondition for that object to identify what are the possible values that that object might have. It can also identify relationships between values. So it might not necessarily be able to tell you that a given output has a certain value, but it might be able to tell you that output X is greater than output Y after the end of the subprogram. Or, for example, if it's a sort routine, it could tell you that the elements of the array are sorted when it's done. It may not know what values they have because that's determined by the input, but it could perhaps tell you that the output is now sorted. Other things that CodePeer can infer by analyzing the subprogram is it can find whether there are any calls within this subprogram on code that has not itself been fully analyzed. When you run CodePeer, you can identify what subset of your whole program that you'd like it to analyze, and then it will detect places where it's making calls to unanalyzed code, and will identify those places and indicate that there may be some analysis that can't be performed, and that allows you to know exactly how relevant are the results. Another thing that it does when it encounters a call that's unanalyzed, it looks how the code at the call point uses the result of that call. And if it makes an assumption that that result, let's say, is not null or is greater than 0 or is in a certain range, we call that a presumption. And presumptions are associated with unanalyzed calls, and they tell you, well, how did I use the data coming back from this call that CodePeer was not able to analyze. Finally, there are two other things which again have to do with the overall effects of the subprogram. Globals, inputs, and outputs are clearly very important when you're trying to understand what a subprogram is doing. You can look at the parameters, those are part of the declaration, but knowing what globals it affects are generally not defined. There may be a comment, but the comments may be incomplete or even misleading. CodePeer does an as-built, if you will, analysis of the subprogram and the things that it calls to determine overall what are the globals, inputs and outputs that it references or updates. Finally, the subprogram may create new objects on the heap and return a reference to such objects. And that can be very important for understanding what are the storage implications of calling this subprogram, how many objects it's creating, what are the overall storage expense of using this subprogram. And again, this is something that CodePeer provides as in an as-built documentation section. And therefore, when you're doing, let's say, code review, you don't have to necessarily stare at the code for hours to understand what's going on. CodePeer can give you these sorts of hints about the overall effects of the subprogram.